today I will solve the problem of magic will save the world of Codeforces round 894 Div.3. Okay, so it was really a nice problem. So here we have been given that. So here our character Vaika has to defeat n monster that emerge from the portal one after another. So one after another, the n monsters will come and Vaika has to defeat all of them. So she possesses two magical powers, water magic and the fire magic. In 1 second, Vaika can generate W units of water. In 1 second, Vaika can generate W units of water and F units of fire mana. Okay, she will need. Uh, so basically, she will have to expand these water or the fire mana she is gaining every second to defeat the monsters. Initially, Vaika has 0 units of water and mana and 0 units of fire mana. Each of the n monsters that emerge from the portal has its own strength. So basically, we have been given the strength of the monster as a positive integers. So to defeat the ith monster with strength SI, Vaika needs to cast a water spell on a fire spell or a fire spell. You can see. So I can say that suppose if a monster with strength SI comes, then to destroy that, to defeat that monster, mana will Vaika spell will cast spell either water spell, either water spell or fire spell, water or fire spell, and not both of them at the same time. Okay, so casting a spell would will cost some units of mana. Either means either if she is casting water spells, then it will cost some units of means SI units of water mana, or either SI units from the fire mana. In other words, Vaika can spend at least SI units of water mana on a water spell, or at least SI units of fire mana on a fire spell. That's what I have explained. So Vaika can create and cast spells instantly. So Vaika can cast an unlimited number of spells every second as long as she has enough mana for that. So what this line is explaining is to you that suppose SI is the SI is the strength of the monster of the current monster. Okay, and at a particular instant, suppose WT and FT is the uh, water or fire mana you see currently have. Okay, so you know that each second, suppose at the t time, either of these, neither a WT or FT is sufficient to defeat the monster with strength SI. So obviously she will have to cast some more, she will have to wait for some more second, because each second you know that these two quantities would be increased by plus F and plus uh, F every second. So when it will become sufficient, then she would be able to cast spells. So that's why it has been stated that she can even wait for unlimited number of spells every second. Means unlimited number of what I can say that she can wait for any time until she would be able to defeat the monster. So now we have to tell means how much minimum time she will need to defeat all the monsters. So we have been given W, F, and then N. The W is the amount of water and the fire mana that Vaika can generate per second. N is the number of the monsters, and then we have been given the strength of the monster. Okay. So now we have been given we have to output the minimum number in seconds that Vaika will need to defeat all the monsters. Okay. So let's discuss the test cases. Then you will be more clear with the solution. So this was the first test case, 2 3 3, then 2 6 7. So this is the W and F. Now, so it has been given that initially it was 0 and 0. So now in the first second I can say the water mana would become 2 and the fire mana would become 3. So you can see that C can use either of them because both are greater than equals to the strength of the first monster. So suppose I am using this, so it will become 1. Now in the other second, it will again be added by 2 and it will again increase by 3. So it will become 4 and it will become 4. So now you can see that neither of the water or the fire mana is sufficient to defeat this monster having strength 6. So she will have to wait for another second. Now it will become again plus 2 and plus 3. Now it will become 6 and it will become 7. Now you can see 6 and 7. She can use 6 and 7 to defeat the monster. So that's why I can say that in 3 seconds, uh, she will be able to defeat all the monsters. Now, uh, let's move on to the solution part. I hope the question is clear to you. Uh, Also, let's just explain the second test case also. The second test case is 37 and 58, and then 1 and 93. So the only monster is having the strength 93. So you can see that at this instant, neither 37 or nor 58 is able to defeat the monster having strength 93. So I will have to wait for the other second. That's why answer is here 2. Answer is here 2 for this test case. So yeah, I hope the question is clear now. So let's move on to the solution part. So before going on to the solution, you should know about the bit set, and there are basically two concepts I will be using this in this problem. First of all is binary search BS. Okay, let me just first tell you why I am using binary search, where I have got the intuition to use the binary search. Suppose Suppose mid is the amount of time in which I am able to defeat all the monsters. Okay, so if I am able to defeat all the monster in mid amount of time, I will always be able to defeat all the monster in mid plus one amount of time. So I can say that whenever I will also tell you that whenever you have been asked minimum or maximum, and you are able to just conclude this kind of stuff. Let me just first complete this. But I am not sure about mid minus one. Okay, mid minus one, because I can say that if suppose mid was the minimum time in which I can minimum. So I can say that if this is the minimum, then obviously I will not be able to defeat all the monster in mid minus one time, because if I would be able to defeat all the monster in mid minus one time, then obviously this would be our answer, no? Mid minus one. If I am not able to if I am not able to defeat in mid minus one, then only our answer is mid. That's why it is kind of monotonic. And whenever you encounter a monotonic function, then binary search should comes to your mind. Or I can say you a trick that suppose we have been asked a minimum or maximum, or you have been asked to you have been and you are able to conclude this type of concept that with the mid it is possible, or mid minus one it is not possible, or mid plus one it is not possible, then you should think of the binary search. Okay, so yeah, binary search is completed. And the second concept I would tell you is that subsets, generating subsets, checking for the subsets, checking for subsets using bit set. Suppose you have to check for all the sums between 0 to 10 to the power 6. Uh, why 10 to the power 6 particularly? Because bit set is safe until 10 to the power 6, I can say, as per my experience. So 0 to 10 to the power 6, and you have been asked to, suppose you have been given an array. You have been given an array A1, A2, AN, and you have been asked which are the possible sums. Means that you have been asked to just choose a subset randomly, and you have to tell whether this subset would result a particular sum s or not between 0 to 10 to the power 6. So I am saying that whenever you have been asked to find to check for every sum whether this sum is possible by taking any subset of the subset of elements from this array or not, then and the sum is at max 10 to the power 6, then one thing you should always think of the bit set c++ stl. I will also give you a overview of the bit set, but I would just recommend you that you should learn the bit set. Okay. Suppose you have been given 1, 2, and 3, and now you have been asked what are the possible sums. So by observing, you can see that say that 1 is possible, 0 is possible if you have not chosen any element in that subset. 2 is also possible if you just choose 2, and 3 is also possible. Then 4 is also possible if you choose 1 and 3. Then 5 is also possible if you choose 2 and 3, and 6 is also possible if you choose all of them. So suppose if I just represent them in the form of bits, means what I can say that I will take a number having 7 bits, each representing the sum 0, 1, 2, 3, 4, 5, 6, 7, and if the corresponding bit is set, then I can say that that sum is possible. So that's what bit set also do. Okay, so it's kind of masking. If you know about masking, then you will be able to understand the bit set. Okay, so now let me generate. I will use a formula bit is equals to. So first of all, I would take a number I can say of 7 bits here, and I will just set the zeroth bit. Why? Because obviously zero sum will always be possible. That's why. And now I will use a formula bit and left shift AI. Why I am using this, I will tell you. Now, suppose I have included one in of this array. So I will just first of all right shift, left shift. Okay. So it would become one, and then I would have to take or. So you can see now 0 and 1 both are possible if I just taken the array till index 0. Okay. Now suppose I have also included 2. These all are one. Now you can see that according to this formula I will have to first of all shift this, so it will be appended by two zeros, and now I would have to take or, so it would become this. So I can say 0, 1, 2, 3. You can see that 0, 1, 2, 3 all are possible if I just take the array till this. Okay, suppose I am now including 3, so again it will become like this 0, 0, 0, and now I have to take the or, so it will become 1, 1, 1, 1, 1, 1. Now you can see this is the final bit set, and you can see here that every sum between 0 to 6 is set, and that's what we have discussed no earlier, that all the sum possible between 0 to 6. So this is the idea of the bit set, and now let's move on to the original solution. So I will apply binary search, and first of all I will just use the bit set to generate all the subset, okay, which are possible, subset sum which are possible, using that formula bit is equals to bit or AI. Okay, first I will do this, means I will just pre-store all the subset sum which can be possible. And now what the my approach is that, suppose I am checking, I you know that I am applying the binary search. Now suppose mid is the time for which I have to check. Now how to check? Now I am telling the approach how to check, for mid time. Okay, so you should think of like that. Suppose uh, obviously you know that we have been given S2, S1, S2, S3 means the strength of the monsters. Okay, so if you just think of like that, what I am doing here, obviously I would have been means Vika would have been using the water spells on some of the subsets of the monsters, and means she would be defeating some subsets of the monster using water spell, means which I have marking with red, and some of them would be defeating by fire. Okay, so I can what I can say is that if I am able to check, if somehow I am able to check from 0 to sum, means sum is the total sum of the strength of monsters. Okay, so what I since I am not able to just say that I will just suppose in somewhere between s for this sum, I will just assign these monsters, and for this sum minus s, I will just defeat by fire. I am not able to say that, so that's why I will check for every 0 to sum. If I am able to defeat in mid time, so obviously I can say that mid can be my possible answer. Mid can be my possible answer. But for that also, I need to be sure that this sum s can be made possible by choosing a subset in such a manner that would be sum up to s. What I'm saying is that if I am able to say that yeah, this sum s is possible for a subset of the given array, then obviously sum minus s would also be possible. Okay, and also this sum, suppose I am this sum s, I am trying to defeat the monster using the water spell, so that should be less than w max, which is, since till time mid, I can say what is the amount of the water mana Vaika has accumulated. It should be mid into W, obviously, and this should be less than equals to, means the quantity, means the monsters having strength this much, sum minus s, means the sum of the strengths which I am trying to defeat using the fire spell. So that should be less than f max. F max, that is equals to mid is the amount of time, and f, because every time you because you know that every time it would be increased by w, and it would be increased by f. So how much time? Mid. So that's why till this time it would become mid into w and mid into f. So this was the all about the approach, means w s should be possible first of all, and s should be less than equals to mid into w, and f max should, and s sum minus s should be less than equals to f max, which is equals to mid into f. And similarly I will also check for the f and s, means vice versa, means here if it is uh, what I am saying, that it first I have assumed that I am using fire spell here, and water spell here, and fire spell here. Now I will assume that I am using fire spell here and water spell here. Okay, so I will have to check both of them. Okay, so yeah, that's all about the approach. Let's move on to the solution. Increase the number of test cases, then W, F, and N. What is happening? I will also have to take the bit set. Always just make sure here it should be a constant value. Why I'm taking 10 to the power 6 plus 1, because I have already explained this, the strength of the monster is 10 to the power 4, and then can be at max 100 monsters. So 10 to the power 4 into 100, it would be 10 to the power 6. Okay, So I will take the strength of the monster, then I will add it to the total sum, and I will also update the bit. Now uh, I will apply the binary search. Low is equals to 0, high is equals to 1 9 plus 7, then mid, then answer is equals to 0, while low is less than equals to high, mid is equals to low plus high minus low by 2. Now I am checking for the mid time. Okay, so what I have already discussed, I will go for every sum possible. Less than equals to sum s plus plus. What I will say is that if bit of s means if at is s is possible, before that I will keep a variable check is equals to false, and if somewhere this s is possible and also s is less than equals to, I can say mid into w, means this is the maximum amount of water mana c would have been acquired till time mid. Okay, so she can cast up to only this much spell. Okay, and also means up to this much of water spell, and sum minus s can be the maximum, will be less than mid into f. If this is so, then okay is equals to true, and I will break, means I have got my condition. So we check. Similarly, I will also check for the means I will just reverse the case. I will just copy this. Uh, Here it should be sum minus s. Here it should be sum. Okay. So if check, then yeah, this can be my possible answer. But I would also try for a lower time. I is equals to mid minus one. Else low is equals to mid plus one. Now finally I will just print the answer. I have already taken the input. Let's run over it. Sorry, I would have just made any mistake. Oh, I just forgot to set the 0th bit. Bit dot set 0. Now you can see that test case has been passed. So yeah, that's all about the solution. Thanks for watching.